Hello students, welcome once again to my channel, and we have an integral problem over here, and we are going to solve it. So we have the integral 10x divided by 4x squared minus 8x plus 9 dx. So we have to find the integral of this. Now see, such integrals are sometimes complicated to solve, so we have to use some mathematical properties or principles to solve them. Now if you look at the integral over there, now if you look at the denominator, we have a quadratic function over there, and in solving this quadratic function, you realize that when you solve it, you are going to get an imaginary value, and so we are going to use completing of squares to solve the denominator. So using completing of squares, using completing of squares, the denominator over there will just give us, so the denominator will just be that square then plus 5. Now this, when you use the completing of squares principle, this is what we are going to get. Now I'm not going to go through that step, but if you have a problem with solving with such completing of squares, you let me know in the comment section, and then I will get back to you. So this is what we have, and we are going to replace this with the denominator over here. So we have 10x here divided by 4, then x minus 1 squared plus 5, then the x. Now made very simple. Now what we are going to do is that we are going to introduce a variable, so we are going to use a substitution over here. So we say let u equal to x minus 1, right? So if u is equal to x minus 1, and we find du dx, we differentiate du with respect to the x. You realize that then I substitute the value of u here. You realize that then I have to differentiate with respect to u. Now differentiating with respect to u, we still have x over here. So the best thing is that we are going to change all the s values to u. So we are going to replace the s values with 2. Therefore we are going to make s the subject from here. So making s the subject from here, we have u plus 1 being equal to x, and therefore x is equal to u plus 1. So we are going to replace the value of x into the integral over there. But before that, we have the x over here. Therefore we have to calculate, we have to find the x du. So the x du is just 1, because this one goes away and we have u. So 1 minus 1, 0, any number raised to the power 0 is 1. So we have the s being equal to du. So let's do the substitution now. So we have the integral 10x divided by, so the x value here is just u plus 1. We are replacing the s values. Then we have 4. Then over here u is just x minus 1, so we just have u, then the squared plus 5. Then we have the x here, so the x is just equal to du. So we have this. Now writing this, we have 10, so we expand this, 10s plus 10 divided by 4. So we have 4u squared plus 5, then du. So now we are going to integrate with respect to u now. So let's continue here. So we have so let's separate them or integrate them separately. So we have 10x here divided by 4u squared plus 5, then also, so which is du, then also, so we have 10 divided by 4u squared plus 5, then du. So I just separate them, but it's still the same. Okay, so this is what we have. Now another, if you look at the denominator, we have to introduce another variable. So let's say let v equal to 4u squared plus 5, so that the v du, the v du is just this one multiplies that, 4 multiplies 2, just 8u. So we have 8u as that. Then we are going to replace it. So we have that. Okay, all right, so this is u, this is u, not x. Okay, so we have respect to u here. So this is what we have. Then so we have 10u here, then divided by, now u squared, 4u squared plus 5 is just v. It's just v, then multiplied by du, and du from here is just du is equal to dv over 8u. So we place here by dv over 8u. U gets rid of u, then 2 goes here 4, 2 goes here 5. So we have over here we have 5 over 4 outside, then we have 1 over u, then 1 over v, sorry, with respect to v. Then this side, for this side we are going to introduce a trig function over here, because if you look at the property over here, it looks like a trig function, and we are talking about the tan inverse. So we are going to introduce that trig function over here. So we have now for tan is just tan inverse of x is equal to this property, is equal to something like this. So we are going to write over here, we're going to write the whole of this in terms of this. We're going to write the whole of this in terms of this. But before that, let's so when we do that, now we are introducing a trig function, because when we put the value of v in here, then we multiply it by du is dv over u. So you can see that we have u value, the u still there, but we are integrating with respect to v, not u. So the best thing is to introduce a trig function. So we're going to write this in terms of this. So this is going to look like so in order for us to get the one value here, we divide each of the side by 5. So we have 10 here divided by 5, then 4u squared divided by 5 plus 5 divided by 5, then still with respect to u. So we have 10 2 here, so we have 2 at the top there, then 4 over 5 u squared plus 1, then du. So this is what we have. All right, so again, what I'm going to do next is that I want to get 1 plus s squared to stand alone. So that's the u squared over here. So I'm going to multiply here by 5 over 4, then multiply each of the side by 5 over 4. So 2 multiplied by 5 over 4, then also 5 over 4, then it goes away, then 5 over 4 here. All right, so we have 5 over 4, still here 1 over v dv. So we are still working on this part. Now in this side I'm going to get 2 cancel itself, and goes here 2. So we have 5 over 2, and we can bring it out so that we have 1 over u squared plus 5 over 4, then du with respect to du. Now this function over here looks like this, and therefore we can go on to substitute with the tan inverse. So we are going to integrate this. Now for the tan inverse, when we are integrating something like this, so we have a property. So look at the property here. If you have the integral of 1 over, let's say, s squared plus a squared, something like this, then this should be equal to 1 over a, then also the tan inverse of x over a plus c. So with this property over here, we are going to integrate this with respect to that. So we still have 5 over 4 here, the integral of 1 over v, then dv. So let's do that here. But before we do that, now you see it's 1 over s squared plus a squared. So we have 1 here, we have s squared, which is u squared, then we have a squared, but it is 5 over 4. So to make this equal to that, then we have to introduce a square root here. We introduce a square root here so that this will be equal to that. So let's do that. So we have 5 over 4, the integral of 1 over v dv, plus 5 over 2, then the integral of 1 over u squared, plus the square root of 5 over 4 du. Then therefore we can go on to do that now. So we have so now let's integrate. So integrating the whole of this is 1 over a. Then in this case a is just this, a is just that. So if a is just that, then we have 1 over square root of 5 over 4. Then the tan inverse, we are using this property. Then x is just what is here, so that is u in this case. Then over a, and a is just square root of 5 over 4. Then plus c. So we still have, now when we integrate 1 over v, integrating 1 over v, we just get the ln of v, right? So we have this. So we have 5 over 4, then the ln of v here, plus 5 over 2 here. Now let's write this well. So we take this to the top, so that we have the square root of 4 over 5. Then the tan inverse of this goes to the top there, so it's just 4 over 5, then multiplied by u. Then we have c here. Now this is what we have, but we said that we equate u to something, so let u equal to that. So we substitute that into it, but v is equal to u squared plus 5. So we have 5 over 4, then the ln of 4u squared plus 5. Then over here we have 5 over 2, and the square root of 4 here is 2. Then we have root 5 here. Then the tan inverse of the square root of 4 is 2, so we have 2u over root 5, then plus c. So from here we have everything in terms of u now. So then again we let u equal to x minus 1. From beginning we started that we let u, which is here, so we substitute that also in. So if u is equal to that, then we have 5 over 4, then the ln of 4, then we introduce that squared plus 5 here. Then over here 2 gets rid of 2, then we have 5 root 5, then the tan inverse of 2 multiplied by u, and u is just s minus 1, then over root 5, then plus c. So this is what we have. So therefore the square root of the integral of 10x 4s squared minus 8s plus 9 is equal to 5 over 4, then the ln of 4x minus 1 squared plus 5 here, then 5 over root 5 here, the tan inverse of 2x minus 1 over root 5, then plus c. So this is what we have, and I hope you enjoyed this section and this video is helpful. Thank you very much, and I'll see you in another section.